Okay, today we're going to look at another application of the triangles in a circle that we've been looking at for the last week or so. So we've looked at finding missing angles by using the properties of the triangle. So in this triangle at the top here, that is a triangle in a semicircle because the longest side here, the hypotenuse, is also a diameter, which meant that any two chords from either end of the diameter that met at the same point on the circumference created a right angle. And then this triangle at the bottom is created by a radius meeting a tangent, which creates a right angle. So this triangle with the blue edge here is also a right angled triangle. Now that was very helpful when we're trying to find angles, but it also means that we can use some other tools. So we can use Pythagoras, and we can also use the trigonometry, the SOHCAHTOA, that we were looking at before Christmas. Okay, I'm going to look at Pythagoras today. So here is an example. So we have a triangle here. It goes through the centre and to either edge on the diameter here, which means this edge, or this angle, is a right angle. Because we have a right angled triangle, we can then use Pythagoras to find out the diameter of the circle, because this length here marked x is the diameter. So if you remember Pythagoras, we have x squared equals 4 squared plus 3 squared. So that's 16 plus 9, which is 25. X then is the square root of 25, so x is 5 centimetres. Okay, the next one. This one's similar. We're being asked to work out the length A to B, so the length along this tangent. The tangent meets this radius here, which means that that angle there is 90 degrees. This one's slightly different to the last one in that we're asked to find one of the shorter sides, because the longest side of this right angle triangle is going to be this 10 centimetres, because that is opposite our right angle, so that is the hypotenuse of the triangle. So we have to use the short side formula. I'm going to call this side x, just make it easier for my formula. So x squared is 10 squared minus 6 squared. So that's 100 minus 36. So x squared is 64. We have to take the square root to find what x is. So the square root of 64, x is 8 centimetres. So this length A to B is 8 centimetres. Okay. Now here's one that looks a little bit more complicated. There's a bit more going on in this diagram. It's symmetrical around the diameter up the middle here. The length of this radius is 6.5 centimetres. And then we have a tangent along the bottom. And the radius meets the tangent, which means that that is a 90-degree angle there, which is creating us some right-angled triangles. Because it's symmetrical, we know that this base here from the centre to the edge here is going to be half of this whole length, which means that that part there is going to be 7.5 centimetres. Okay, now I'm going to break this up a little bit to make it easier for us. So I'm going to draw another little diagram. So in my red pen, we'll have the red triangle, which has a length of, or a height of 6.5 and a length of 7.5. And I'll call this length R, because that is my red length. Okay, so R squared is 6.5 squared plus 7.5 squared. When you put that into a calculator, it comes out at 0.5. So R is the square root of 98.5, and R works out, once it's rounded, as 9.9 centimetres. So that is the length of half of the red wire, one side of the triangle. Nothing on the left hand side yet, we worked out, just doing the right. Now we're going to do the same with the blue. We'll draw a triangle. When you're working these out, it's fine to do a freehand sketch of the triangle. The whole purpose of this is so that you know what is happening and you can communicate to the reader what you're doing. So the base is still 7.5 centimetres, but the blue wire goes right to the top of the diameter here. And now remember earlier we said that this length here was 6.5 centimetres, and that is a radius, so the diameter is going to be twice that length. So 6.5 times 2 is 13. And I'm going to call this B for blue. So B squared is 13 squared plus 7.5 squared. When you put that into a calculator, it comes out at 225.25. B is going to be the square root of that. Which, once you round it, comes out at 15 centimetres. Okay. So the difference between the two lengths of wire for one side of this diagram is going to be 15 minus 9.9. So the difference for one side is 5.1 centimetres. So the total is going to be 5.1, not 5.2, 5.1 times 2, which is, let's put it down here, 10.2 centimetres. Okay, so that's the difference between the length of the red wire and the blue wire.